today. I don't have your tests graded yet, but we are starting the last unit that we cover in Algebra 2, which is all on trigonometric or trig functions, trigonometry. How many of you next year are signed up to take trig pre-calc? Okay. So trig pre-calc, this is, kind of an introduction. Some of this will be review from geometry, like what we're covering today. I know you've seen sine, cosine, tangent before, but then also kind of leading into maybe some things you didn't cover in geometry that you will cover more in depth in trig pre-calc if you are taking that class. For today, I have the first part of chapter 12 is remembering or going over the trig functions in right triangles, and I have this split into today and tomorrow. Today we're just practicing finding values of trig functions. So we'll just get started here, and then as you have questions, let me know. Okay, so first of all, what I have at the top is if we're studying trigonometry, it's good for you to know what trigonometry is and what trig ratios and trig functions are. So trigonometry is the study of relationships among the angles and sides of a right triangle. And trigonometry also gets into a lot with circles and the unit circle, so we'll actually be previewing that. You would get more in depth with that in trig pre-calc, again, if you're taking that class. A trig ratio or a trigonometric ratio compares the side lengths of a right triangle. So there's 3 trig ratios, sine, cosine, tangent, and then also their reciprocals, cosecant, secant, and cotangent. And then a trig function has a rule that's given by a trig ratio. So we're really just getting into the trig ratios today. I have up here as well, I know in our last unit with statistics, we got into where some of the notation involved Greek letters. And we see that in trig as well. You will probably see, and you probably have seen before, the Greek letter theta. So it looks like an O with a horizontal line through it. That is often used to represent the measure of an acute angle in a right triangle. And I'm just going to highlight acute here. What does acute mean for angles?
Below 90.
Below 90 degrees, less than 90 degrees. Okay, and that's important just because sine, cosine, tangent, today we're focusing on sine, cosine, tangent, those trig ratios for acute angles. So not for the 90-degree angle in a right triangle, but for either of the 2 acute angles in a right triangle. Bless you. And then the hypotenuse, the leg opposite theta, and the leg adjacent to theta are used to define the 6 trig functions. So I just have up here a right triangle, triangle ABC. Angle B is the angle theta. And part of finding your trig ratios is being able to understand where the hypotenuse of the right triangle is and then where the legs opposite and adjacent to the angle measure are. So hypotenuse is always across from or opposite the right angle. So side AB would be your hypotenuse. And it might seem silly to label these, but as you're going through it, just so you're not getting your ratios mixed up, because if you have the side lengths labeled wrong, all of your trig ratios are going to be incorrect. So label them if that helps you. And then the side that is opposite theta, should make sense. Opposite the angle, across from the angle would be AC in this case. That would be the opposite leg. And then adjacent in math means next to. So the angle or the side that is next to the angle, that is not the hypotenuse. That is the adjacent side. Okay, so as you work through, again, if it helps to label them, I would recommend doing that. Maybe once you get more comfortable, you won't need to. But then based on the opposite leg, adjacent leg, and then the hypotenuse, that's again how these 6 trig functions are defined. So down in this box here, we have if theta is the measure of an acute angle of a right triangle. So again, I'm going to highlight that just because that's important, that theta is not the 90-degree angle. Then the following trig functions involving the opposite side, the adjacent side, and the hypotenuse are true. And then make sure as you're pronouncing these or as you hear me say them, part of it is making sure you're saying them right. So sine is written as S-I-N. So it's not sin, it is sine. The actual word is S-I-N-E. So sine of theta is the ratio opposite leg over the hypotenuse. So in this example here, they do have the example below. If this is theta, the opposite leg is 4, hypotenuse is 5, so sine is 4 over 5. Cosine is C-O-S, so it's not cos. I hear cos a lot. That is cosine. So cosine of theta is the adjacent leg over hypotenuse. So again, in this triangle, the adjacent leg is 3 over the hypotenuse is 5. Tangent, T-A-N, so don't just say tan, it is tangent of theta, is the opposite leg over the adjacent leg. So that would be 4 over 3 in that right triangle. And then we have these 3 trig functions as well. These are the reciprocal functions. So cosecant is abbreviated CSC, so you'll see CSC theta, so that's cosecant. And that is hypotenuse over opposite. Notice that is the reciprocal of sine. So cosecant of theta is really the reciprocal of sine, so it's 1 over sine of theta. So if sine of theta is 4 over 5, cosecant of theta is 5 over 4, just the reciprocal. And then secant, S-E-C, secant of theta is hypotenuse over adjacent. That's the reciprocal of cosine. So you see again in the example, cosine of theta is 3 over 5, secant is 5 over 3. And then cotangent, C-O-T is cotangent, that's adjacent over opposite. That's the reciprocal of tangent. So tangent in that example was 4 over 3, cotangent is 3 over 4. Okay, so really, you only need to remember the ratios of sine, cosine, and tangent. And then as long as you know which trig function is the reciprocal of which, once you know those 3, you can just take the reciprocals to find the other 3. So you wouldn't have to memorize these ratios for cosecant, secant, cotangent, as long as you know what they are the reciprocals of. And then you may remember this from geometry as well, SOHCAHTOA, to remember sine, cosine, tangent. And there's different ways it could be written. So SOHCAHTOA, sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. So just remember the ratios for sine, cosine, tangent. SOHCAHTOA is a mnemonic device that can help with that. Is this coming back from geometry? Or maybe it never went away. You're recognizing it from geometry. So I have the first 3 examples, actually the first 2 on the front page, top example on the next page, are finding the values of the 6 trig functions for some angle, some acute angle. So in example 1, it says find the values of the 6 trig functions for angle G. So I'm just going to draw in that angle. That's the angle we're focusing on. And so this is what I would recommend if you have the triangle already drawn. If it helps, label what side is your opposite, adjacent, and then your hypotenuse. So first of all, which value here is representing the hypotenuse? 24, 32, or 40? The 40, the side opposite the right angle, or you may remember the hypotenuse is the longest side in a right triangle. So 40 is the hypotenuse. And then with respect to angle G, is 24 or 32 the opposite leg? Which one's the opposite leg? The 24 is the opposite. The 32 then is the adjacent leg. So I'm going to go ahead, I'm going to find sine, cosine, and tangent of angle G first. So if I'm finding sine of G, I would write it this way, S-I-N with a G after it, sine of G. And that ratio is the opposite leg over the hypotenuse, so 24 over 40. Leave it as a ratio, leave it as a fraction, but as always, all fractions should be simplified. So I can divide 24 and 40 both by 8. So that would be 3 over 5. Sine of G is 3 over 5. And then cosine of G, so C-O-S followed by G, cosine of G. That ratio is adjacent over hypotenuse, so that would be 32 over 40. And again, I can divide 32 and 40 both by 8, so that's 4 over 5. And then tangent of G, so T-A-N-G, is opposite over adjacent, so that would be 24 over 32, which again can both be divided by 8, so 3 over 4. And then I still need to find it once all 6, so I need to find the 3 reciprocal functions. So the reciprocal of sine is cosecant, so CSC of G. I don't need to remember the ratio as long as I remember that's the reciprocal of sine. If sine is 3 over 5, cosecant is 5 over 3. And then the reciprocal of cosine is secant, so S-E-C-G, secant of G. If cosine is 4 over 5, secant is 5 over 4. And then the reciprocal of tangent is cotangent, C-O-T. Cotangent of G, so if tangent is 3 over 4, cotangent is 4 over 3. And I will say, in terms of remembering which reciprocal function goes with which, so obviously tangent and cotangent are easy to remember that they're reciprocals of each other. For the other two, if you look at each pair, I want you to notice that one of the two in each pair starts with a C, or starts with a co. So you wouldn't put cosine and cosecant together because they both start with C, or they both start with co. So you have sine and cosecant, cosine and secant, tangent and cotangent. Each pair has a C with it. If that helps you remember for the sine and the cosine which one goes with which. Okay. Otherwise, if you have a different way to remember it, that's fine too, but just trying to give you some helpful hints. So any questions on that? That's probably review from geometry, identifying the values of sine, cosine, tangent. So then for number 2, this is the same type of problem, it's just not set up the same way. So it says if tangent of angle A is 5 over 3, find the exact values of the 5 remaining trig functions for A. So here you're not given the triangle. I would draw the triangle, so I would just sketch a right triangle. Doesn't matter how you sketch it. And then not your 90-degree angle, but one of your other 2 acute angles label as A. So I'm just going to label the one that's at the bottom right, the way that I drew this. And I know that tangent of angle A is 5 over 3, and tangent is opposite over adjacent. So I know the side opposite angle A, which would be this side over here, that must be 5. And the side adjacent to A, that's not the hypotenuse, that would be this bottom leg here, is 3. Okay, so you're setting up the right triangle. So then I should be able to find what the hypotenuse is, which then would allow me to find the remaining 5 trig functions. How would I find the hypotenuse? Pythagorean theorem, yes. So a squared plus b squared equals c squared. And C, all you need to remember in this formula is that C is your hypotenuse. The A and the B, the two legs, it doesn't matter which one is which. So I would have 5 squared, so 25, plus 3 squared, which is 9, equals C squared, so 25 plus 9, well, I'll just put equal to C squared here. 25 plus 9 is 34. And then to solve for C, I would have to take the square root of each side. Do not give a decimal. I'd rather you leave answers as exact. So if it's not a perfect square, leave it in radical form. However, you have to think back also, I still want your answers simplified. So this is thinking back to chapter 6 when we simplified radicals. If there is a perfect square that goes into your value here, you should simplify the square root. So is there a perfect square that goes into 34? I see some no's already, so I can't divide it by 4, I can't divide it by 9, can't divide it by 16, and then the next one's 25. That's not going to go into it either. So this is already simplified, so I would just leave it as the square root of 34. Okay, so that's my hypotenuse. So now that I have all 3 sides, I can find my 6 trig functions. So, and I already have tangent of A. So I'm going to find sine of A. So sine of A, and I could have labeled this as well. 5 was the opposite leg, 3 was the adjacent leg, square root of 34 we found was the hypotenuse. So sine of A is opposite over hypotenuse. So 5 over the square root of 34. Now you may remember from chapter 6 as well, square roots that are in the denominator, that's not simplified. So you can't leave the ratio like this, it's not in simplest form. Anyone remember how we got the square root out of the denominator? You have to rationalize the denominator. So we had to multiply both the numerator and denominator by the square root of 34 to cancel it out. So multiply top and bottom by the square root of 34. And that means on the top, I can't multiply the 5 and the 34 because the 5 is not in a square root, the 34 is. So that will just stay 5 square root of 34. But on the bottom, square root of 34 times itself, that cancels out the square root, so it's just 34. It essentially becomes the square root of 34 squared, so the square root and the squared cancel out. Okay, so this would be simplified, and then you should just double check in this case, like 5 and 34, this 5 and 34, that I can't simplify those further, which I can't. So that's sine of A. Cosine of A is the adjacent over the hypotenuse, so 3 over the square root of 34, which then I'm going to have to do the same thing, rationalize the denominator, so multiply the top and bottom by the square root of 34. So along the numerator, I'll have 3 times the square root of 34 over, and again, my denominator will just become 34. And then even though I was already given tangent of A, but just to kind of complete this, I'm just going to rewrite what tangent of A was. That was 5 over 3. Okay, and once you have those 3, again, the reciprocals aren't that bad to find. So reciprocal of sine of A is cosecant of A. And now when I find the reciprocal, I'm not going to use the simplified answer for sine, because if I use the simplified answer, I'm going to have a square root in the bottom again. If I go back to my original ratio when I found opposite over hypotenuse, where that square root was in the bottom, if I take the reciprocal of this, that puts the square root in the top, so it's going to be the square root of 34 over 5. Okay, so I just went back to that original ratio so I wouldn't have to rationalize a denominator again. Reciprocal of cosine is secant of A. So again, if I go back to where I wrote 3 over the square root of 34 and take the reciprocal of that, that's the square root of 34 over 3. and then cotangent of A, reciprocal of tangent, which would be 3 over 5. Here's my paper. Any questions on those? So setting it up on your own and also just reviewing how to work with radicals a little bit. So what I'd like you to do on the next side, example 3, I'd like you to answer this one on your own, compare with your groups. So you're given sine of angle B is 5 over 8. Find the remaining trig functions. And then we'll check it and just make sure we're all on the same page. Okay, I know not all of you are totally finished, and then some of you are, so what I would at least check, be careful what trig ratio you're given to begin with. You are not given tangent like we were for the previous example. You are given sine, which is opposite over hypotenuse. So your opposite side is 5, your hypotenuse is 8. You have to find the other leg. So using Pythagorean theorem, make sure you get that other leg to be the square root of 39. That is simplified. And then check your ratios if you did have that. So sine we were given, cosine is square root of 39 over 8. Tangent, fully simplified, is 5 square root of 39 over 39. And then cosecant is 8 over 5. Secant, when you take the reciprocal, you have to rationalize the denominator. So 8 square root 39 over 39. And then cotangent is square root of 39 over 5. Okay, so if you didn't quite finish, I can always show that again a little bit later if you need to check your answers there. So knowing how to find, identify the 6 trig ratios. The next part I just want to get to that I can pass out the practice as well. So I have here right above that box, you will see this in this unit. If you're taking trig pre-calc next year, you'll see this next year. The angle measures of 30 degrees, 45 degrees, and 60 degrees are very frequently used, or they occur very frequently in trig. We're going to be covering what's called the unit circle, and that's really focusing on these special angle measures. You may remember from geometry special right triangles. So there's 30, 60, 90 right triangles, and there's 45, 45, 90 right triangles. So still tying in with those frequently occurring angle measures. So I have on here, because these are special right triangles for 30 degrees, 60 degrees, 45 degrees. I need your attention up here, please. That means the trig ratios, sine, cosine, tangent, have special measures for those angles. So when you're looking at these formulas, you may remember for a 30, 60, 90, so the short side, which would be opposite the 30-degree angle, if we just call that x, I'm also just going to label here, I'm going to put a 1 there. That means the long side, the side opposite the 60-degree angle, is the short side multiplied by the square root of 3. So if x is 1, this would just be 1 square root 3, or just square root of 3. And then the hypotenuse is 2 times the length of the short side. So again, if x is 1, that hypotenuse is just 2. So if you look at this, that's where they're getting these ratios from. So if we start with the 30 degrees, sine opposite over hypotenuse, opposite is 1, hypotenuse is 2, that's why they're getting 1/2. Cosine of 30 degrees, adjacent is the square root of 3, hypotenuse is 2, that's where this is coming from. Tangent of 30, opposite over adjacent would be 1 over the square root of 3, and then they rationalized it, that's where they're getting the square root of 3 over 3 from. And then they're doing the same thing with the 60-degree measures. It's just your opposite and your adjacent sides have now switched. So those ratios kind of switch. And then for the 45, 45, 90, again, because it's an isosceles right triangle, those two acute angles are the same measure. Both legs are then congruent. So I'm going to call those both a leg of length 1. Hypotenuse is the leg multiplied by the square root of 2, so 1 square root 2, or just the square root of 2. And that's where for either of these, since your opposite and your adjacent sides are the same, sine and cosine of 45 degrees are both the same measure, square root of 2 over 2. Tangent is opposite over adjacent, so that would just be 1. So how we're going to use these in examples 4, 5, and 6, and you may need to reference this as you're working on the practice as well if you're doing that. So it says use the trig function to find the value of x. I did say to leave your answer in radical form, so do not use a calculator to round your answers. So in example 4, we have a 30, 60, 90 triangle. The 30 degrees isn't labeled, but if we have a 60-degree angle, the other acute angle is 30. And we need to use a trig function to find this value of x. So what you need to identify first is if this is my angle, the 60 degrees, what sides do I have in relation to that angle? Do I have the opposite, adjacent, or hypotenuse? Which sides do I have? So what would the x be? Opposite, adjacent, or hypotenuse? I'm hearing opposite. The opposite side of the 60 would be up here. So x is the adjacent leg. 14 is opposite the hypotenuse, or opposite the right angle, so the hypotenuse, ladies. So if I have the adjacent leg and the hypotenuse, what trig function uses adjacent and hypotenuse? Cosine. So I would set this up as cosine of 60 degrees, cosine of my angle, is equal to the adjacent over the hypotenuse, so x over 14. And then I would solve this for x. Now, I do not want you to type this in a calculator. I know that you could, but because some of our trig ratios involve square roots, I want you to leave it in exact radical form. So I would then reference this up here. The cosine of 60 degrees is 1/2. So in place of cosine of 60, I know that value is 1/2. So 1/2 is equal to x over 14. And then I can solve this for x, which, how would I do that? I could cross multiply. This is a now proportion, so I can cross multiply. So I have 1 times 14 is 14 equals 2 times x. So 14 equals 2x. Divide both sides by 2. And I get x is 7. Okay, so I know if you typed in a calculator cosine of 60 degrees, it would give you 0.5. But the reason I'm having you use these is if you got something like the square root of 3 over 2, that's not going to show up in the calculator that way. So then if we look at example 5 as well, this is another 30, 60, 90 triangle. I have my 60-degree angle here. X is what side in relation to the 60? The opposite, adjacent, or hypotenuse? Here, x is the opposite, 12 is the hypotenuse, opposite the 90-degree angle. So here I have opposite and hypotenuse. What trig function is that? Sine is opposite over hypotenuse. So I would have sine of 60 degrees is equal to the opposite is x over the hypotenuse is 12. And then I can reference what is sine of 60. Go up to my chart. Sine of 60 is the square root of 3 over 2. That's the exact value. So square root of 3 over 2 equals x over 12. And then I could do the same thing here. I have a proportion, cross multiply. So I have the square root of 3 times 12. That would just be 12 square root 3 equals 2 times x. Divide each side by 2. And here I can divide the 12 by 2 since that's not in the square root. So that becomes 6 square root 3. And that is my exact value of x. Okay, so I'm looking for your answers in that form, not in decimal form. Okay, so I'd like you to do number 6. Solve that for x using a trig function. I will pass out your worksheet 12.1A. As always, recommending you do that practice to be more familiar with these as we build on it throughout the chapter. Make sure your answer is in simplest form as well. So exact answer in simplest form. All right, if you didn't have it done when I walked around, you can just double check. Otherwise, you have your practice. Correct that tomorrow. Let me know if you have questions. Have a good day. You can go.
every time I say that, I don't know anything.
Hopefully, if you feel good, hopefully it goes well then.
Melanie Wallace, feeling well. Please report